So in that case, I guess we'll move on to our next speaker, and that would be Michael Watson. He'll talk to us about There's No Place Like Home, an astrophotographic tour of the Milky Way.
Thank you, and I'll just make sure that that I can be heard. I hope so. Thank you everybody for and Paul for inviting me to back to the Toronto Centre to speak about one of my favorite topics. This is a presentation that I made a couple of years ago at the RISC General Assembly, and I have added some new photos and replaced stuff, and so I'm going to take you on a tour. And so I'm going to start by asking, actually, sorry, this question: what is home? And so, there are lots of ideas about what home is. Where you go to at the end of your workday. Although during the pandemic, it actually has been, where most people actually have been working. In baseball, it's managing to hit an inside the park or outside the park home run and slide into home base. But for astronomers, what we really talk about and what I like to think about as home is this, and that is our Milky Way galaxy. And this, of course, is similar to a view that we see with our human eyes, which are not very well equipped to detect color at low light levels. I think most people understand that. It's only really the planets, bright stars, and in the case of solar eclipses, for example, the solar the prominences and corona that are bright enough to trigger the cones in our eyes that let us see color. And so basically what we see is gray tone. But when we turn the astrophotographic camera on the heavens, this is what we see. And this is one area, and actually the only one, I think, in which one can truly and properly and accurately say that the camera captures reality better than the human eye can see it. Low level viewing of dim objects at night. And so I call this presentation, borrowing from The Wizard of Oz, There's No Place Like Home. And so what I'm going to be doing is showing you astrophotos that I've taken, all of them between 2015 and 2020. And using this gear. So this is my stuff set up in Algonquin Park. A lot of it that you'll see toward the end of this presentation from the southern sky is me set up in the red outback of Australia, and on various trips over the years. And I should tell you that all of these photos that you're going to see have total exposure times ranging from 5 minutes to 30 minutes in total, with numerous subframes stacked. Most of them are in the 12 to 16 minute range. All of them are taken with a Nikon D810A DSLR. And every time, because I don't have a permanent observatory and I live where I am right now in Midtown Toronto, every time I go out, I have to pack all of this gear in the car. And when I get up to Algonquin Park, set it all up, or when I get into the outback in Australia, ship it down, take it down with me. I wouldn't do that now. It gets lost between, Pearson and any other airport you're going to, and set it up. So, it's a bit of a challenge. But the fact is that this astrophotography that you're going to see, and some of you have seen it, particularly on my Flickr page, you've seen it before, has to be done from a dark sky site. And that means in Southern Ontario, at least 2 hours out of Toronto. And so moving on then, what does the Milky Way look like? If we were to go away from our Milky Way galaxy and look back at it, what would it look like? Well, we can't send a camera out there, but I think that the best example of that is this, and everybody knows what this is. This is M31, the Great Andromeda Galaxy, with M32 and M110, the satellite galaxies. Now this the Andromeda Galaxy is about 2.5 million light years away from us. It's about 1.5 times the diameter of the Milky Way. And so if we were to go out to the Andromeda Galaxy, which you can't do all the time, you need at least a long weekend to get out there, and turn around and look back at our Milky Way galaxy, you would see something that looks a little bit like this, but probably about 2/3 of the diameter. That would be our Milky Way galaxy. Now, one thing that would be just a little bit different, M31, as we can see in this photograph, is tilted about 12.5 degrees from the horizontal to our line of sight. So it's open just a little bit. If you were to go out there and look back, our Milky Way galaxy is actually tilted about 21.5 degrees, so another 10 degrees. It would appear more open to the observer in the Andromeda galaxy than M31 looks like from here. So let's then go on, and this is one of the oldest photos. This is one of my early ones with a good DSLR, and this was in 2015, a super wide-angle view of the Milky Way from Perseus up in the upper left to Scutum in the lower right. It's a very, very wide-angle view taken in August of 2015. But what I'm going to do is in this presentation start with go from little areas and constellations that we're familiar with. And so we'll start with the northern Milky Way, and in the constellations of Perseus and Cassiopeia. Everybody is familiar with them. Starting around midnight or 1 o'clock in the morning now, you can see them rising in the northeast. They are fall constellations. And so let's take a look at this. And what we're going to be seeing here is an area that is about 135 degrees away from the center of our galaxy. So about a third of the way, where the center of our galaxy is in the constellation of Sagittarius. It's about 1/3 of the way around the sky, around the galaxy from the center. And that's what we're going to be looking at here. And so it will not probably jump out at you what exactly this is, but for those of you who are familiar with my astrophotography, you'll know that I always do labeled versions. So let me show you what this is. We can see here on the right the W, the familiar W, if you can see my cursor, of Cassiopeia. All right, and then we see here what was just being talked about, the double cluster, H and Chi Persei, two NGC objects. This is the constellation of Perseus through here, Andromeda over here, and then this is Cassiopeia. And what I should tell you is that for most of these, I show open clusters of stars as green circles, and then hydrogen alpha red emission nebulae that tend to be pink, well, they are very pink, shown in that color. So just going back then, if we can see here, you can see that there are lots of open clusters of stars. I'll be talking about them again in just a little bit, and some hydrogen gas clouds as well. We tend to get more of them as we get closer to the center of the galaxies. We get down into the Cygnus area, and we'll be seeing those. So this is a really great area. This is a much closer in view than of the double cluster, taken with a 6-inch or 152 millimeter telescope that has a focal length of about 1,250 millimeters in order to get it close in. So that's the double cluster. And this one, again, I believe that this dates from 2015, actually. Nearby is one of my favorite objects, and that is the California Nebula. This one I shot in August of 2019, and this is with my favorite astro scope, and that, or astrophotographic scope, and that is a Teleview 660 millimeter focal length lens. It's really great because it gives you a field of view of about 3 degrees by about 2 degrees, and you can get the full object here, the entire California Nebula in really well. So I really like this telescope a lot. Let's then go just in a little closer to Cassiopeia. And here what we're seeing again is the familiar W. You can see the double cluster there in the lower left. And they're all this area is absolutely strewn with open clusters of stars, and it's even a small telescope. They're just gorgeous to see. You are not going to see the colors of the nebulae, but you will be able to see the faint hazy patches of the nebulae that will appear gray to you. So moving on then, now we're moving in really closer with longer exposures, total exposure times of these objects. This is what's called the Sol Nebula. There are two of these very close by, as we could see from the previous photo. This is the Sol Nebula, taken in October 2018, and about a year earlier, you will then. This is the Heart Nebula. Now, this is really interesting. Incredible shape to this. I should tell you then, and probably all of you, many of you will know this. All of these objects that show red are what are called emission nebulae, and so this is ionized hydrogen gas that is excited to glow by nearby hot stars. And it is therefore the case that most of these nebulae are associated with young open clusters of stars that emit radiation that then cause the adjacent gas to glow with the characteristic reddish glow of ionized hydrogen. And we see this again and again and again. All right, so this is the Heart Nebula. Okay, and here we see, so you can see actually here, I have shown several of the open clusters of stars that are located, sort of embedded within and associated with this nebula. Let's move on then to another very familiar constellation. We're going actually just a little bit further into the fall and even winter sky. And this is Auriga, one of my favorite constellations. And of course, we have the bright star, and here I'll show it again. We see the bright star Capella, the first magnitude star, over in the right side. This is a 50 millimeter lens shot from 2015. And one of the great things about Auriga is this: you don't see hydrogen gas clouds, but there are numerous open clusters of stars, including some of the famous ones in the Messier catalog. And here we can see I'll just show with my cursor, M37, M36, and M38. And there, it's beautiful just to star hop that with a small telescope and see these beautiful glittering open clusters of stars. I'm going to show some closer in views here, but we can see that then in Auriga. So let's then go to, sorry, just get it. Yeah. So we'll go to these. And so this is a photograph then taken. This is actually one photograph taken with a 200 millimeter lens. And I get all three of these objects in here. And what's really interesting, I put all the information there. We can see, how far away they are. They're actually really close by, because the distance from where we are located, about halfway or so from the center of our galaxy to the edge of the Milky Way, from our location to the center of the Milky Way, maybe a third of the way, is about 27,000 light years. These are really close. You can see that these open clusters are in the neighborhood of 4,000 light years away. They're just next door. They're in Mississauga to Torontonians. But you can see also that they're very different in appearance. All of these, M36 is the smallest one there. M37 on the left is probably the most concentrated and the richest, and then M38 on the right side there is really quite spread out and is much larger. And so we see different personalities for all of these, and I really like that a lot. Okay, so moving on. Here then are three closer in views of these three objects that I've just put together in sort of a collage. Okay, so those are the open clusters in Auriga, and these are all then within our Milky Way galaxy. I should also say, and I think you'll probably know this, or you may know this, that open clusters of stars, a couple of things about them. First of all, they're called clusters because they are loosely gravitationally bound together. And as a result, while they do and can dissipate over time so as to become unrecognizable, not in your lifetime or mine, they are gravitationally bound together. But because also they do dissipate over time, it means that any recognizable open star clusters are actually very young, on the order of, say, 1 to 5 million years of age. After that, they've just dissipated, and you don't recognize them as clusters anymore, as opposed to globular star clusters that have a completely different origin, are very densely packed together, are tightly gravitationally bound to each other, are billions of years old, a good portion of the age of the universe, and can last for billions of years. And we'll see some photographs of those. So then, Moving on, we see, and this is all part of the Milky Way and close to the plane of the Milky Way, sometimes outside the plane of the Milky Way, but all part of our own galaxy. We have some very familiar objects. This one, several tens of degrees away, is a similar star cluster in Gemini. I really like this one. We actually you see here M35. It's very large, and then another NGC one that I think unfairly doesn't get enough publicity. A really beautiful object there, and we see that. Now this one is further away. You can see this is 12,000 light years away, so almost halfway in a different direction, but almost halfway from where we are to the center of our Milky Way galaxy in distance, although not in direction. And so in the northern Milky Way, we have a lot of very well-known objects, and everybody knows this one. This actually is a fairly short exposure because it's really it's quite bright. Taken in September of 2017, the Rosette Nebula in Monoceros, which is further south, taken in March 2017, a winter object. I'm not spending an awful lot of time in this presentation on this part of the sky, mainly because it's too cold to photograph it well, unless you're in the southern hemisphere. But this is the belt and sword of Orion, taken with a 200 millimeter lens. And of course, we can see here the belt, 3 stars of in the belt, the Zeta Orionis nebula. And here we see the Horsehead Nebula, and then of course the Great Orion Nebula M42. Closing in just a little bit, we can see the Horsehead Nebula there, and then some reflection nebulosity. When you see blue, that indicates reflection rather than emission. It is gas that is reflecting light from a young bluish hot star, as opposed to ionized hydrogen that is that is fluorescing or emitting light, and that tends to be red. And then the Orion Nebula again. I'm not going to spend a lot of time, as I say, on this. So let's then go now closer down toward Cygnus, and we get to the not quite as well-known constellation of Cepheus. It's large. It doesn't have any really, really bright stars. And what we can see here then is in the lower right, we'll see the North American Nebula in Cygnus, and then it really is Cepheus. What we're seeing. And you'll see a very large hydrogen gas cloud there, which I'm going to take you to right now. And this is one of my, well, we can see here again all sorts of these objects. There are all sorts of open star clusters and these various clouds of gas. This is one of my favorites. This is what's called IC meaning the index catalog, 1386 in Cepheus. It's also sometimes called the Elephant Trunk Nebula, and I think that what you'll see here, if I can show that, you'll see down here the so-called elephant trunk. That's why it's called this. And one of the very noteworthy things about this object, a very large gas, is this one, Herschel's Garnet Star. Now, William Herschel was a great English astronomer, and he observed that this had a very obvious garnet color. The star that causes this gas cloud to emit light and to be visible, this star is 100,000 times brighter than our sun and is 1,000 times our sun's radius. It's not really known with any degree of precision how far away it is, 3,000 or 5,000 light years. It hasn't really been measured all that well. But this is one of my favorite areas, and it's really fun to photograph as well. So then, moving on, we get to the summer triangle, and everybody knows this. And we know that the summer triangle, consists of the 3 bright stars Vega and Deneb and Altair. They're very different stars. So here is a photo, 35 millimeter wide angle lens of the summer triangle. And what I'm going to do here is show you then the 3 bright stars, Vega in the constellation of Lyra, Deneb in the left side, the constellation of Cygnus, the swan, and then Altair in Aquila, the eagle, at the lower right. And so these stars are unmistakable. I should tell you that Vega was the first star that I looked at when I got my first telescope in May of 1970, which is also when I joined the RASC 52 years ago. And we can see also in Cygnus there the stars of the familiar Northern Cross. But in this area, it's staggering how much there is to see. We see various objects that are familiar to us, including the Dumbbell Nebula, which I'll be showing a little bit later. So let's move on. So that's the Summer Triangle. This is a very wide angle view, but we're now going to go to one of the easiest and most beautiful to observe constellations with a whole host of objects, and that is Cygnus the Swan. And here we see one of the really, really interesting aspects of the Milky Way is that, as we saw with the Andromeda Galaxy, it isn't just one flat plane of stars. There are dust clouds throughout it. And when we see galaxies from afar, we see those dust clouds circulating around, as the galaxy rotates over billions of years. And we can see that as well in our Milky Way. And so here, what we see with all of this dark area here, this is not an area where there's an absence of stars. These are areas, clouds of dark foreground gas that block out the light from stars beyond. This is the great bifurcation or division in two of Cygnus into a much bright area here, and then a fainter area of the Milky Way down here. So this is a standard 50 millimeter photograph. And here what we can see is all of the open clusters of stars and the various gas clouds that are shown so well in astrophotos. But all of the open clusters of stars you can see in moderate telescopes, and they just are absolutely, absolutely gorgeous. So then, right in the middle of and actually, let me just show you, go back here. I'm going to show this area now. Satyr is all of the star known as Gamma Cygni, and in this area, you'll see that there's a lot of red hydrogen gas. So let's go forward in that, and we can see a lot of this. Here is Satyr, and here is Deneb. This is a 200 millimeter view. I'm going to then zoom in on it with my better astrophotographic telescope. And here, by the way, we can see that this is the galactic equator. So this is sort of the central axis of the galaxy, and these gas clouds are very close to it. If we get in closer, you can see the star images are much smaller. This is a real astrophotographic telescope that I use for this, which I really just love, as I think you can imagine. And it really is just a gorgeous view. This area, the star, Gamma Cygni right in the middle, and this area of excited hydrogen gas is about 1,800 light years from us. So a lot closer than most of these very familiar open star clusters. And it's about 100 light years across or so. Nearby is a really pretty little nebula, the Crescent Nebula. I find this difficult to photograph. There are a lot of astrophotographers in the society. Blair MacDonald is one in Nova Scotia who produce wonderful, superb photos of this. But with my portable equipment, no permanent observatory, it's a challenge to photograph some of these. And then we get to a very well-known object, and that is the North America Nebula, obviously because of its shape. This is the bright star Deneb. And I should tell you, this is photographed with a 200 millimeter lens. We see the bright star Deneb here, the familiar shape of North America here. Here's the Gulf of Mexico, and here's Baja California and Mexico, and here we see Florida. And I guess we're someplace up right around here. And then its companion, the fainter Pelican Nebula here, with some dark gas clouds in here. This is the northern coal sack, by the way, or part of it. And then you see little other parts of all around here of red nebulosity. So I really like this a lot. It's a great area, and it's not all that difficult to photograph. But we can zoom in then again a little bit more to the North American Nebula and the Pelican Nebula, and they really are beautiful. Again, I just point out you're not going to see the colors yourself with your eyes, but you absolutely can see the outline, and from a dark sky, the outline of the North American Nebula with your naked eye. And if you have even modest 8 by 30 binoculars, and that's what I use when I'm out in the field, you can make out the shape of that really easily. And you won't see the color, but that will be an achievement for you. And if you can see that, then you are in a dark sky. All right, and that's where you want to get to. Everybody's going to be familiar with this, not too far away. Oh, actually, sorry, no, I should just tell you then that here, this is a wider angle view, and again, we see the North American Nebula, but this is a great dark nebula called Legendre 3, and it's really prominent. You can actually see it as kind of a dark hole in the sky when you're just looking up with your naked eye from a dark site, and astrophotos show it really, really well, and you can see it's a great big cloud of dark foreground gas, and only the few stars, on this side of it can we see. All the rest of the stars are blocked out by it. Okay. And then everybody is familiar with the Veil or the Cirrus Nebula, again in Cygnus. I really like this a lot. It's also a challenge, I should say, to photograph. It's really fairly large. It's essentially a supernova remnant, and the brighter side here is this side, and I will show you then. That a portion of that, and these are the real colors. Again, you can't see them naked eye, but they are the real colors of this object. So then we are moving along, and we're moving down now closer to the center of the galaxy. I just need to check my time. We're moving closer to the center of the galaxy into Aquila. And actually, I should ask Paul, can you tell me about how much time I have? Because I think I'm not going to have enough time, and I do want to get down to the southern sky. I don't know whether you can give me some kind of indication of how much time I've got left.
Yeah, Michael, you can carry on. There is time tonight.
Okay, all right. Well, that's great, and if you want to yank me, you just let me know. Okay, great, thank you. So Aquila, and this is something that I've been starting to photograph over the last 2 or 3 years. There are so many dark nebulae in this area. This is what's called the Triple Cave, or the dark nebulae, and yeah, sorry, let me just go back there. And these were all, most of these are numbered with the letter B for E. Barnard, who was an American astronomer in the early 1900s, who made it his business to photograph and to catalog these dark nebulae. And so whenever you see these B numbers, that's what it refers to. Edward Emerson Barnard, born in 1857, died in 1923. And he is best known for the discovery of the large proper motion of Barnard's star. The star that is named after him. And he published his catalog of originally 182 of these objects, later extended to 370 in about 1919. So then we move on to a constellation that is not really very well known, except for two things. And this is the constellation of Vulpecula. And the two things, well, the first one is fairly well known, and that is Brocchi's cluster, also known as the coat hanger. And let me just point out the various stars here. They're actually fairly bright stars. They're one of them is, well, actually two of them technically of naked eye brightness, but you can see this little asterism or grouping of stars, and you can see it with the naked eye, but it looks really, really great in binoculars. And nearby then something, and you rarely hear of this actually spoken about when people talk about the coat hanger, is this beautiful the little kind of stardust, super concentrated open cluster of stars, NGC 6802. Brocchi's cluster is actually interesting because for decades until really the late 1990s, it was thought to be an open cluster of stars, that is, loosely gravitationally bound together, as I described earlier with respect to open clusters. But it is now really, it has been demonstrated that it actually is nothing more than a random chance alignment of stars that just happen to be in a coat hanger shape, but they're not really close enough to affect each other and to attract each other gravitationally. So I think that this is kind of an interesting thing, and I didn't know that until until recently. Then we get, of course, to M27, the Great Dumbbell Nebula. This is taken with my larger telescope, the 6-inch refractor, 152 millimeters. Again, that has a focal length of about 1,250 millimeters. Also called the Apple Core, located about 1,270 light years from us, and it is this is not a supernova remnant. It is the visible remains of a low mass star's expelled gaseous sort of outer envelope. With an X-ray hot white dwarf star in the very center of it, and in this photo you can see stars down to about magnitude 17. So then into scutum, and we see here we're getting closer to the center of the Milky Way, and we can see that it's starting to bulge out. All spiral galaxies, have thin sort of pancake-like arms, and then these larger central bulges. And the central bulge of our galaxy, of course, is in the constellation of Sagittarius, and from our latitude, it never gets higher than about 20 degrees above the southern horizon, and as a result, we don't get to see it very well, which is why every astronomer, every observational astronomer wants to get into the southern hemisphere, where you see the center of our Milky Way galaxy directly overhead, and the whole galaxy is displayed for us overhead from horizon to horizon. It's just a breathtaking and, frankly, first time somewhat frightening view to see. And so, if you get a chance, absolutely do that. And so here we see various of the smaller constellations here. This is Aquila, and over here Serpens. Scutum is a small is a small constellation here. And by the way, a constellation is not a pattern of stars. A constellation is a defined area of the sky. So when we talk about Ursa Major, well, that's the name of the constellation. But the Big Dipper is not a constellation. It's simply a recognizable pattern of stars within this particular area. Okay, so we then move in a little bit closer, and now we start to see some of these well-known objects. And dead center here, you heard some discussion before about this, M11, the wild duck. I photograph this almost every time when I get a clear sky, and that's this open star cluster here. This one is with a 200 millimeter lens, so it's not all that close. But what you see here is the incredible intricacy. You see all of these are Barnard globules of dark gas. Each one of them has a particular designation, and you see the incredible detail that you can get with a good lens. This is a 200 millimeter Nikkor lens with long exposures, and you see the way I take my photos, they're stopped way down, and so the stars are almost pinpoints, or right to the very edge. The other thing you see here, and I noticed this some years ago, is that you get a distinct color shift from the center of the galaxy, which tends to be more orange yellow, to away from the center, which tends to be bluer. And I have seen that, and it's not an effect of altitude. I can tell you that from having photographed it in various locations. So on the left side here, we can see that this is a lot bluer, and on the right side, we're starting to get a lot more orange yellow. And so the color balance really is significant. And here again, you can see all of the Barnard globules that I've labeled here, and various of the open clusters, and one globular cluster. But let's then move in a little bit closer. And this then is the wild duck. This is one of my most recent photos. Last year was an almost total wipeout because of weather, but this was in June 2020. This is one of the richest and most compact known of open clusters, almost 3,000 stars. The age is estimated, this is actually fairly old for an open cluster, of about 250 million years. And the reason for that, I think, is that it's not a globular cluster, but it's fairly densely packed together, and so the stars have an immense gravitational effect on each other. It takes a lot longer for it to dissipate into sort of a lack of, you can't recognize it as an open star cluster anymore. And so here we see again, I've just labeled it with the various data. I'll just move on. And then we get to the center of the Milky Way in these four constellations. And here we see this, and this is the central bulge of the Milky Way. I'm going to come back to this in just a little bit. This is photographed from the center of Australia back in 2019. And here we see now, and you wouldn't have been able to pick it out because of the richness of the stars. We see the familiar teapot of Sagittarius. I'm going to go back, by the way, to the previous ones, without the lines, and then the tail of the Scorpion with Antares, the first magnitude star in Scorpius here, and then the tail down here, and below, down in this side. This is below our horizon. You can't see it from the northern hemisphere. Our horizon goes about here. All right, and so here we see the teapot of Sagittarius. Let me just go back and see whether you can pick it out at all. Just keep your eyes focused on Sagittarius there. And now you look at it, you couldn't pick that out at all. And now you can with your naked eye. It is a little bit easier, except for the southern hemisphere, because everything is upside down. And boy, is that discombobulating the first time you're south and you're trying to pick out the teapot, and it's apparently, upside down. That is really difficult. And what I do is I turn myself like this, looking straight overhead, and suddenly then looking backwards, I can pick it out, and then I turn myself around. Oh, that's what it looks like from the south, because it's just completely different. Okay, center of the Milky Way, and we can see then a little closer in view where the center of our galaxy is, where is thought to reside, a black hole. One of the great globular star clusters is M22, and in fact, it is the second brightest of all of the globular star clusters. I photographed this this was photographed actually from Australia. You just can't get a good enough skies. It was extremely high up, almost straight overhead, so easy to photograph. Here, it's really tricky to photograph because it's so low. This is one of the first globulars to be discovered. It's magnitude 5, so you can see it naked eye, and it's actually fairly close, 8 to 10,000 light years away. So going on, we see now, and these are familiar objects. This is with a 200 millimeter lens. We see the Sagittarius and Serpent star clouds, and these are all going to be very familiar to us, M17 and 16, the Lagoon Nebula M8 and the Trifid Nebula M20 here, with open clusters all over the place, just strewn in this entire area of the sky. And then the great M24 star cloud, which is one of the most unusual objects, maybe the most unusual in the Messier catalog. Here we're in just a little bit closer, again, photographed from Australia. You can see the extreme detail that you can get when you photograph in the southern hemisphere. This is the M24 star cloud, which I really do like. It's very obvious naked eye. I photographed this in June 2020 from here, from Algonquin Park. And then moving on, we then start to see some of these familiar objects. The Omega Nebula M17, which is reasonably well visible from here. This was not one of my best photos. This was early on in 2016. We then move on to the Eagle, what's known as the Eagle Nebula. Now, I should point out that you see in the label here, you see IC 4703 and then M16. IC 4703 is actually the Red Emission Nebula. M16 itself is actually the star cluster in the center of it. And so with the label here, we can see where the star cluster is, and then the very famous pillars of creation, photographed famously by Hubble decades ago, which is one of its most famous photographs. This photograph by me is a little less famous, but that's okay. it's fun to be able to photograph something like this. Then we move on to this one I really like. It's sort of turned on its side. North is to the left and south is to the right, because you can get with an appropriate focal length both of these objects, the Lagoon Nebula at the right side, and then the smaller Trifid Nebula at the upper left. Trifid Nebula is really, really interesting because, as you'll see, the actual colors are blue, which indicates, again, a reflection nebula, and the red, which is an emission nebula. And then from the southern hemisphere, when the Lagoon Nebula gets really, really high up, you can get way more of the red nebulosity in a dark sky. And this is one of my favorites because it really shows this object in a way that I find very difficult to photograph here in the northern hemisphere. And we get the tail of the scorpion, and here just a slightly closer in view. One of the really great objects is M7, a very large open cluster, which is really very bright. And this then is the area of Antares and the Rho Ophiuchus Nebula. I've managed to photograph this only once, and I don't know why. This actually comes from September 2015, and this was taken with a 200 millimeter lens. So that's what we can see. And I'm going to finish up here then with a dozen photographs or so, or maybe 20. The southern Milky Way, what we can't see from the north. But it is just the, the most exciting part of the Milky Way as far as I'm concerned. Although Cygnus is not too shabby. And here, what we see here, now this is a very wide angle view, and I really want to orient you to this. So I'm going to bring up the labeled version. And what we see here then, if you can see my cursor on the left, Alpha and Beta Centauri. Alpha Centauri is no longer called that. It's called Regal Centaurus and Hadar, very bright stars in the constellation of Centaurus. Here we see Crux, the Southern Cross, way smaller than the Northern Cross in Cygnus, but very obvious. Although I should say as well that to the west there is another cross that's just slightly fainter that rises before. That rises before the true Southern Cross, and because people are misled by that, and they see this cross, which is slightly larger, rising first, they think, "Oh, it's the Southern Cross." No, it's not. The Southern Cross is still below the horizon. This one is called the false cross because it is visible first. But here what we see is, and you'll see a closer in view of that, we see the Northern Cross, and then over here the Eta Carinae Nebula. One of my, probably the last photo I show in this shot is a closer in view of that. And you will all be familiar with the fact that 2 weeks ago, the operators of the Webb telescope released as one of its photos a small portion of the Eta Carinae Nebula. And so you'll see the fuller thing. And so this is one of my photos that the Webb telescope can't take because it has such a narrow field of view compared with my stuff. Anyway, so this is a wide-angle view of this area of the sky. And here what we see then is the coal sack closer in, and I think you probably can pick out the stars of the Southern Cross here. They're really quite bright, and what we see here then, this is taken with a 135 millimeter lens, and we can see there the coal sack. This is the again the galactic equator. So this is right on the central axis of our galaxy, with the coal sack and the various open clusters of stars all over the place here. Really beautiful to see. Now, one of the things that I now want to turn to. We saw M22, the globular star cluster. The brightest globular star cluster in the entire sky is this one called 47 Tucanae. And it's not an M object, obviously, because Messier was never in the southern hemisphere and could never see this. It is the brightest one. M22 in Sagittarius is the second brightest, and originally it was mistaken for a star when Ptolemy first saw it, and hence he gave a number 47 in the constellation of Tucana to it, rather than, for example, it also has an NGC number and so on, but that's why it's called that. This one, I find a little difficult to photograph because it's very densely concentrated, and so I had to do a lot of work to so that the center of the globular cluster wouldn't be completely blown out. And then, and what we could see here is that 47 Tucanae is very close to the Small Magellanic Cloud, and I just wanted to show this so that you could actually see, how close they are. This was taken in September 2015 when I was down there with a 200 millimeter lens. We then get to one of the most interesting objects in the entire sky, and I'm getting really quite close to the end now, and that is this one, Omega Centauri. Now you'll notice that in the label here, I do not say globular cluster. It was thought to be a globular cluster until about 20 years ago, when new studies showed that it is the vast likelihood is that it actually is a dwarf galaxy remnant, with most of the galaxy, because it's fairly close to our Milky Way, or very close in fact, only about 15,800 light years away, and it has been blown off. So that's a beautiful one to see. And then finally, last two ones, and actually I'll just go to this one. Here is the Eta Carinae Nebula. This was a photograph I wanted to get for years, and finally managed to get a reasonably decent one, September 2019. Center of the Milky Way, and I will then finish up simply by saying that we then have the Magellanic Clouds, and you can see both of them here, Southern Milky Way, large and small Magellanic Clouds. A little bit closer, the small cloud, and then the large one with the Tarantula Nebula. And that then will finish that up, and all I will say then is this. There's no place like home, and thank you very much. And I hope that wasn't too long, Paul.
No, that was fine for this evening, Michael. Thank you so much. We did have the extra time. Fabulous images, Michael, and of course, always a pleasure to have you speak to us. It's great listening to you. Emma, do we have any questions for Michael?
Yes, we actually have a couple of questions and a couple of comments as well. First comment comes in from Stingray Ray, who says, "Great stuff." Eric Briggs wants to know, he just bought a hydrogen beta filter, which is known for only being for observing the Cocoon Nebula, the Horsehead, and the California Nebula. Will he be able to see anything on other nebulae with it?
Well, yes, I'm going to say yes, and I think probably the question has to do with a visual filter, and not necessarily one that is for astrophotography. That will tend to increase that filter visually will tend to increase the contrast, and so it'll make it a little bit easier. But the problem is, it depends on what you're using it for. In a telescope, you see the North American Nebula just fills the entire field of view of even a rich field telescope, and so the problem is you're not really necessarily going to be able to see it. Because in order to see that you're seeing a nebula, you need to be able to discern the edges of the nebula where it's darker beyond, and then you can say, oh yeah, I'm actually seeing a nebula. And so with larger objects, it makes it very difficult to say, oh yes, I'm actually seeing the nebula. You got to see it smaller and in context is the way I would answer that.
Great, thank you.
Okay.
Paul Markov has a question for you. Which software do you use to process your images, and approximately how much time do you spend processing each image?
Oh, good question. I stack all of my images in a program called Registar, but I use a PC. I don't use a Mac. That's all I've ever used, and I use Photoshop. And I've been using Photoshop for 15 years, and I do all of my processing there. I'm not an expert processor by any means. For the entire process to assemble an image, not to do the labeling, because that can take 2 hours or more, but just to process the image so that it's sort of acceptable, will take me on the order of 45 minutes to an hour. Sometimes for someone where I really have to play around, it can take up to 2 hours. So that's approximately it.
Wow, thank you.
Okay.
We got 2 more comments. TQ Michael says, I remember when you used to do this using gas-treated cut 35 millimeter film in a Schmidt camera using very, very long exposures.
Yeah, that's right. I used to have a Schmidt camera, and that was film, and that shows how long I've been around.
And another comment coming in from CDB45. Wonderful presentation and pictures.
Well, thank you very much. It was a pleasure sharing them with you, and I hope that it inspires you because yes, I've got some good equipment, but anybody who is prepared to get into a dark sky and spend a little bit of money on just a tracking mount and a decent lens and 35mm camera can produce really memorable photographs. So you can all do it. You can all do it. Okay.
That's great.
Alrighty.
We got another question coming in from Rask Toronto. Have you considered photographing from the top of the Andes, specifically in Colombia? It's at a high altitude and turns into a grassland at parts. It's virtually uninhabited, near the equator, and without light pollution.
Yes, it absolutely is that. I've seen a solar eclipse from the Atacama up there, by the way, but I haven't taken my gear down there. It's very difficult to get it up there. But the other thing is, and the reason I go to Australia is also when we go on our trips, my wife and I, we go to see the southern hemisphere, to go hiking, but also because of all the great wine regions in Australia. And so during the full moon part of it, we're in wine country, the Barossa Valley and so on. And when it gets to be new moon, then we're driving into the outback, and you don't quite get that up in the Atacama. So yes, I've thought about it, and a lot of people do go down there, but I have a marriage to preserve as well.
Great answer. We got another comment coming in from Sue, who says, this was an excellent presentation with clear explanations and beautiful photos. Thank you.
Oh, well, that's very nice. It's very kind of you to say that. So thank you for the comment. I do appreciate it.
I've got a question for you.
Sure.
What objects would you recommend to photograph for a beginner?
Well, listen, what I'm going to say is the moon, and I've got presentations on the moon too, and I think I'm known as a bit of a lunar photographer. But if you're talking about the deep sky, where you have to get into a dark sky, first thing is photograph constellations. It's a lot easier, and you can do it with a standard lens, even a 50mm lens with fairly short exposures on a tripod where you don't need a motor-driven clock drive. You can shoot with a 50mm lens up to approximately 20 seconds without getting any noticeable star trailing. And so that's the way to start. And I think that I'll just finish up here. The point about starting off is choose something where you're going to be able to get a good result right off the bat, where you'll say to yourself, I did do the right thing in choosing astronomy as a hobby, because I can actually do this myself, and you will be able to do it. So I think that far too often people get into look at all these beautiful photos of the nebulae and so on. And I've been doing this for close to 50 years, and so it takes a lot of time, but you can get good results doing wide angle stuff, which I love, and I still do a lot of wide angle stuff. Not without effort. You need effort, but very early on, without a huge amount of time. So that's how I'd answer that.
Thank you.
Okay.
We got 2 more comments. Richard Conley says,
Paul's going to be yanking me off.
Okay, we'll wrap it up. As an Aussie, he can verify the wine is amazing. And Zap Fan says Chile has wine regions too. So.
That is true. That is true. Not up in the Atacama, mind you.
Well, that's it from comments and questions.
Okay,
Thank
great.
you.
All right. Thank you again, Michael. Great having you. We're looking forward to having you on in the future.
Thanks, Paul.